In section 2.6, we're going to apply the trigonometric ratios to solve triangles. To solve a triangle means to determine the measures of all the angles and the lengths of all the sides in the triangle. Again, we're going to use the three trig ratios that we learned throughout this chapter. So in example 1, we're asked to solve triangle XYZ, give the measures to the nearest tenth. So we have a number of ways we could go about doing this. We could use Pythagoras' theorem to find the third side because it's a right triangle. We could use trig ratios, so there are more than one way to get to the desired answer. But to start with, I am going to find angle X. Again, you want to be specific and neat when you do these. So to find angle X, okay, I have the side that is opposite angle X, and I have the side that is adjacent to angle X. So therefore, if I say tan of angle X is equal to 10 over 6, and now if I take the tan inverse of each side, I'm going to end up getting angle X to be tan inverse of 10 divided by 6, 59.0 degrees to 1 decimal place. Okay, so we know that this is 59 degrees. And now to figure out angle Z, we can just use deductive reasoning because we know the angles of a triangle is 180. This angle is already 90. So therefore, these two angles have to add up to be 90 degrees. So therefore, if I take 90 degrees to find angle Z, I just have to say 90, subtract away 59, and we're going to know that that works out to be that angle Z is equal to 31 degrees. So now I have my two angles that I need to find, and the last thing I have to do is find side Y, and again, I have some options here. Okay, I could use any trig ratio with either of the two acute angles. So let's take a look at, say we're going to use angle 59, and I'll use side 10. So 10 is opposite of 59, and Y is the hypotenuse. So therefore, I could say the sine of 59 degrees is the opposite side, which was 10, divided by the hypotenuse, which is Y. Okay, and now if I isolate Y, again, we've done this a number of times. We said basically these two will just end up switching positions at the end. I get that. And now if I take 10 and divide it by the sine of 59, that works out to be 11.7 centimeters, would be this third side length. So if I go back here, this is 11.7 centimeters. And again, by comparing the angles in the side opposite them, we can see if our answer is legitimate or accurate. 31 is the smallest angle in the triangle. It has the smallest side. 59 is the next biggest angle. It has the next biggest side. 90 is the largest, and therefore the hypotenuse has to be the biggest side. And this all seems to work out, so I think we're quite accurate with that solution. Okay, I want you to pause the video and give this one a try. Okay, I hope you had a chance to try this. Again, let's go about the same procedure as before. First of all, let's try and figure out angle K. So angle K, I'm given the opposite side and the adjacent, so therefore I'm going to use the tangent. So the tangent of angle K is going to be 11 over 7. And if we go arctan of both sides, we'll end up having arctan of 11 over 7 is going to be equal to angle K. So arctan 11 divided by 7. So this works out to be 57.5 degrees is angle K. To figure out angle N, it's just going to be 90 minus 57.5 degrees. Therefore, angle N is going to be 32.5 degrees. So I've got this angle. And finally, to figure out side M, we can use any trig ratio we want. Okay, so this time we'll use angle N, which was 32.5. I know the opposite is 7. The hypotenuse is m. So therefore, I'm going to use the sine of 32.5 equals the opposite side, which is 7, over the hypotenuse, which is m. Again, if I isolate m, I'm going to end up getting 7 divided by the sine of 32.5. And that works out to be 13.0 centimeters if we round to 1 decimal place. So again, there are more than one way. There's more than one way to get some of these answers, but at the end of the day, your answers for all the angles inside should be the same no matter what method you choose. All right, here's one more example for you to try. So again, I encourage you to pause the video and give this a whirl. All right, looking at the last example, we already know angle E is 25, so therefore I can find angle D, and that has to be 65 degrees because angle D and angle E have to add up to be 90. And now I need to find side F and side D to finish solving this triangle. So to find side F, that is the hypotenuse, I'm going to use angle E, and I'm going to use the sine ratio, because opposite of E is 5 and the hypotenuse is F. Therefore, the sine of 25 degrees is going to be 5 over F. Therefore, F is going to be equal to this 5 over the sine of 25 degrees. And side F is going to be 5 divided by the sine of 25. And that works out to be 11.8 centimeters. So F is 11.8. And to figure out side D, again, I'm going to use opposite, which is 5, and adjacent, which is D, in relation to angle 25. So therefore, the tan of 25 is going to be 5 divided by D. And therefore, D is going to be 5 over the tan of 25 degrees. And 5 divided by the tan of 25, D works out to be 10.7 centimeters. And again, looking at our answers, angle F is the biggest, its side is the biggest, angle D is next biggest, its side is second biggest, and angle E is 25, it's the smallest, and across from it is the smallest side. So our answers, again, do seem legitimate. Okay, there is your assignment for today from your textbook 3, 4, and 6. And here is the handout that you can try as well for solving right triangles. So give this a whirl. The textbook answers are on the web page, and the answers to this handout are at the bottom of this page.